Hello, friends. Today we are taking up a new chapter that is on shear strength of soil. In the previous video, you have seen that we have taken all the 5 chapters pertaining to foundation engineering. Now, from geotechnical engineering, this is one of the important topic: how to find out the shear strength of a soil. You have got numerous tests. You collect the undisturbed sample from the site and you carry out the test in the laboratory and you get the shearing strength. And it is very important to know the strength of a material, that is soil, over here. So you know that many a time in a stability of slopes, in bearing capacity, you require the concept of shearing strength. And you need to apply, you need to calculate the shear strength mobilized, the shearing stress mobilized, and what is the uh, ultimate shearing strength of the soil. So that's very important. So few lines on shearing strength I would like to have you. You know that the Coulomb's law, how the shear strength is found out. Coulomb gave a famous equation, tau, which is called the shearing strength of the soil, is given by C plus sigma n into tan phi, where C is called the cohesion parameter and sigma n is called the normal stress and phi is called angle of internal friction. Therefore, the shearing strength tau is given by this was given by Coulomb. Later on, it was revised based on effective parameters and it was called revised Mohr-Coulomb's equation. And it is a very famous equation which all of us know, that the final shear strength or the ultimate shear strength is equal to C prime plus sigma n prime or sigma prime into tan phi prime. This is a famous equation that we come across. So this equation is based on, this is called effective cohesion parameter and this is called effective angle of internal friction. So this is the effective normal stress. In fact, if you have any soil sample which is subjected to the vertical stress, that is under compression, and the confining stress, say the vertical stress is sigma 1 and the confining stress, then the maximum shearing strength will be on any plane which is inclined at some angle. Shear can be given by this equation known as Mohr-Coulomb's equation. So C and phi are the effective shear parameters that we know it. If you draw the Mohr circle, that also is very important that if I have a sample like this, which is subjected to the shearing stress, uh, this is called the minor principal stress, and this is called major principal stress, and this is the soil sample. So if you want to draw the Mohr circle, so easily you can draw the Mohr circle of stresses. So Mohr circle, you can draw it. This plus side of shear strength, it is called tau shear stress, and this side it is the normal component, and you get the Mohr circle like this. So you must have come across this Mohr circle, and you know that the center of the Mohr circle, and this point is called O, this point is called A, and the Mohr circle, if you want to find out on any plane, uh, that is what is the shearing strength of that. Let's say there is a plane, I may call this as B. Now on this plane, which is inclined at some angle theta, so if this sample subjected to sigma 3 and sigma 1 at a plane which is inclined at angle theta, if I want to find out the values, we can do it by drawing the Mohr circle, and it's quite simple. This is the origin. You can join it like this. You can join this point, and this angle is going to be 2 theta. These are the radius. So this angle and this angle becomes equal, and therefore the external angle become 2 theta. This point B, this plane is subjected to a normal stress, which is sigma n, and also it is subjected to shearing stress. So it is subjected to tau. So it has got two components. It has got the normal component, sigma n, and it has the another component is called tau shear stress. So what is the mobilized shear on this particular plane, any plane, normal as well as inclined? You can draw the Mohr circle. Therefore, this point B, if you draw a perpendicular, this is the value of tau and this is the value of sigma n. So from here to here, this is sigma n and this is the value of tau. So the coordinate of B is going to be sigma n and t. So you know it, that how to find it out. This OA is going to be sigma 3, and if I call this point as D, OD will be sigma 1. So I am going to represent here all the stresses like this, and therefore I am in a position to find out this particular from O. This will be sigma 1 plus sigma 3 whole divided by 2 up to the center. Center may be called as O. So up to here it is going to be like this. Therefore, I can find out the equation for sigma n. So sigma n will be simply from the geometry of this Mohr circle is going to be sigma 1 plus sigma 3 divided by 2. So this is going to be up to O2, this is may be called O1. So O2 O1, it is sigma 1 plus sigma 3 divided by 2 plus this is sigma n. So plus this is going to be equal to the sigma 1 minus sigma 3 is the radius. So the radius is going to be sigma 1 minus sigma 3 by 2. So sigma 1 minus sigma 3 by 2. And if you take sine 2 theta, this becomes so multiplied by sine, multiplied by cos 2 theta, because we want the horizontal cos 2 theta. So this is the value of sigma n. And the value of tau, the mobilized shear on that plane, will be simply sigma 1 minus sigma 3 by 2, this radius, into sine 2 theta, vertical component. So from the Mohr circle, we are in a position to calculate on any plane the value of sigma n and the value of tau. So what is the shear it is mobilized? If I am going to have a sample which is subjected to major principal stress and minor principal stress, can be shown over here by the Mohr circle of stresses. So a very simple way we can show it. Also, regarding pore water pressure parameters, Skempton's, that is also important. And you must have learnt about it, that what is the pore water pressure given by Skempton's. So pore water pressure parameters. This is very important. Pore water pressure parameters given by Skempton. You know that the increase in pore water pressure, the moment any soil element is subjected to a pressure, the pore water pressure is going to increase. And when it dissipates, the pore water pressure becomes 0. So when you carry out a triaxial, this if the sample is subjected to major principal stress sigma 1 and minor principal stress sigma 3, then this can be simulated by triaxial test. You perform triaxial test. In the triaxial test, you can take a cylindrical sample and you can apply the confining pressure or the cell pressure, and then the additional axial pressure you can apply till the sample is going to fail. So when you apply the confining pressure or the cell pressure sigma 3, the pore water pressure is going to increase. So the pore water pressure, increase in pore water pressure due to sigma 3, that is the minor principal stress or the confining pressure, is called delta U1. And then in the triaxial test, this is called the first stage, and in the second stage, you are going to apply the additional axial pressure, that is called sigma D or deviatoric stresses. This is equal to sigma 3 plus sigma D equal to sigma 1, because sigma 3 is acting in all directions. Therefore, this becomes in this direction, this becomes sigma 1. So sigma 1 equal to sigma 3 plus sigma d. So delta U2 when you apply the additional axial pressure. That is, so stage 1, when you apply the confining pressure and allow it to consolidate. So consolidation stage. And the second stage, stage 2, which is called shearing, because when you apply the additional axial stresses in the downward direction, the sample is going to get sheared at the weakest plane, and therefore it is called shear stage. Stage 2. So delta U1 and delta U2. And Skempton gave the pore water pressure parameter for stage 1. He gave a pore water pressure parameter which he called it B, and that is due to confining pressure. So what is the increase in confining pressure? B times delta sigma 3. And this stage 2 is combined because the pore water pressure is going to increase in all direction, and in the vertical direction, is in shear stage, it is going to be A into B multiplied by delta sigma D. So when I am applying the deviatoric stress, this is going to be the another parameter given by Skempton. So a simple way you can say this is equal to B into delta sigma 3, and AB can be written as A prime into delta sigma D can be written as delta sigma 1 minus delta sigma 3. So that is the deviatoric stresses. You know it. And therefore, we can say that the value of this delta U2 is a very simple way. We can say it is A prime into the delta sigma 1 minus delta sigma 3. It's so simple way it has been explained. Now, if you want to find out A prime, therefore, will be delta U2 divided by delta sigma 1 minus delta sigma 3. And B also in the similar way can be found out. So you know delta U1 divided by delta U1 divided by delta sigma 3. So this becomes this, and A and B here, A and B are called Skempton's pore water pressure parameters. Now, if the sample is completely dry, when you apply the confining pressure, there will not be any pore water pressure. So B will be equal to, what will be the pore water pressure for dry soil? It will be definitely 0 for dry soil. And B equal to 1 for fully saturated soil. And the value of A prime A prime is, if you refer the table, is positive for normally consolidated clay and also for medium to or the sand which is not dense, you will be getting all positive values up to 3. So value of A prime is positive up to 3. You will be getting up to 3 for normal soils. And it is A prime is negative to 0 for dense sand or over consolidated clay. All those things will be asked in gate examination, so little refreshment was required. So you can just keep these things in your mind. Then all the tests, right from triaxial test, box shear test, Vane shear test. Vane shear test is also very important. You know, Vane shear test for soft clay, we carry out the Vane shear test and try to find out the undrained strength. So you want to find out the undrained strength from Vane shear test of the soil, soft soil. So any soil sample you can carry out Vane shear test and you can find out the value of undrained shear strength SU by applying lowering the blade into the soil mass and then applying the external torque till the soil mass gets sheared. And the formulas are quite simple that you can always remember. It is the external torque that you applied. So you will have to apply the external torque. The blades are here and these blades are lowered and it is inserted into the diameter is going to be D and the height of the blade or the vanes is called H. So, and you apply the external torque so that the soil mass is completely sheared by these vanes. So in Vane shear test, if the vanes have been fully inside the soil mass, it is going to be pi d square into height upon 2 plus d by 6. So you can find out the value of the shearing strength by knowing the torque. And torque can be measured. The external torque to shear the soil sample can be easily this. But the vanes should be here. Only condition is vanes must be fully inserted in the soil mass. That is the condition. If it is partially inserted, let's say the vane is up to this much only, it is inserted in the soil. This is H1, which is less than H. Then SU, for partially inserted vanes, it is the torque divided by pi d square, no change, multiplied by H1 by 2, where H1 is less than H. How much it has gone inside the soil mass, that's very important. So you should be able to measure it and then you should do it plus d by 12. So this is for partially inserted veins in the soil mass. You have got unconfined compression test, for which you draw the Mohr circle like this. In unconfined compression test, what you do, you have the clay soil sample and then you apply the axial stress vertical till the sample fails in shear. So there is a shear plane, and here sigma 3 is 0. You don't apply any lateral pressure. So tau versus sigma will give you this, and this is going to give you Cu equal to Su. So this is done on fully saturated clay. So for clay, you can do unconfined compression test. You can also carry out box shear test. These are the shear test which you must have performed in practical. You must have performed triaxial test. Triaxial test. So in triaxial test, you have got unconsolidated undrained test. We call it UU test. You have got consolidated undrained test. You have got consolidated drain test. Say if it is sand, the pore water pressure will easily escape. You should carry out CD test. So for saturated sand, consolidated drain test. If it is clay, for short-term stability, when the pore water pressure is not dissipating even after application of the load or the pressure, then you should go for unconsolidated undrained test. That means while applying the cell pressure or confining pressure, you don't allow the drainage, so it is undrained, unconsolidated. It doesn't go under consolidation because there is no pore water pressure dissipation. So it is unconsolidated. And in a stage 2, that is shear, stage 2 is the shear state. So it is going to be again undrained. This is consolidated. So when you apply over the sample the confining pressure or the cell pressure, you allow the pore water pressure to dissipate and therefore sample gets consolidated. And while shearing, you don't allow the pore water pressure to dissipate. Therefore, in stage 2, it remains undrained. So CU test and CD test is consolidated drain test. So friends, with this background, you will be able to handle the gate problem now. So on shear strength of soil, let us take the gate problem now. Deliberately, I have given you some idea of shear strength in brief. Now, I will be taking one problem of gate problem of 2020, set 1. It is a CD test, consolidated drain test on a sandy sample. So sample is granular material, it is sandy soil, and this is the sample in triaxial compression. You know that you apply the confining pressure and this is sigma 3. So sigma 3, sigma 3 all round, and then you apply the additional axial pressure known as deviatoric stresses. So sigma 3 plus sigma d, this becomes sigma 1. And the values are here given that additional axial pressure for shearing the soil, that is sigma d, is given to you as 150 kilopascal, 150 kPa. And the cell pressure is sigma 3 prime is given to you as 50 kilopascal. You have to find the angle of internal friction for the sandy sample. So how will you attempt this? So solution of this problem is very simple. You know the relationship. You know sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha. There is a relationship between sigma 1 and sigma 3. Now here, sigma 3 is known to us, sigma 1 is known to us. If you add up, so this becomes sigma 1 prime equal to 150 plus sigma 3, that is 50. This becomes 200 kilopascal. So 200 kilopascal equal to 50 tan square 45 alpha is 45 plus 5 prime by 2 plus 2 into, because in cohesionless soil, sandy soil, there is going to C will be 0. So the second term becomes 0. Or tan square 45 plus 5 prime by 2 equal to 200 divided by 50, that is 4. Therefore, you can find out by simplifying the value of 5 prime. So if you calculate this, so phi prime is 63.43 minus 45. So minus 45. So 5 prime, 5 by 5 by 5 prime by 2, tan 45 plus 5 by prime. So that is 63.43. So 5 by prime equal to 18.43. Therefore, 5 prime equal to 36.869 degree. So this way we can calculate the value very easily. There is no difficulty in calculating it. You can solve it by other techniques also. So a simple problem. And You can also use from sine phi prime, sine phi prime equal to that sigma 1 minus sigma 3 divided by sigma 1 plus sigma 3. If you calculate by using this, the previous problem, sigma 1 you have 200 minus 50 divided by 250. Therefore, 5 therefore phi prime equal to sine inverse of 15 divided by 25. So let us calculate this way also using this formula. So if I use this, shift sine inverse 15 divided by 25, directly you will be getting 36.869 degree. So there is another way of attempting that 2020 gate problem. So either from that or from this also you can find out. So in drain test on sandy soil, you can use this formula and find it out quite easily. The next problem is of 2018. GATE 2018. So 2018. The total horizontal and vertical stresses at a point X in a saturated sandy medium are 170 kilopascal and 300 kilopascal respectively. The pore water pressure is static. Pore water pressure is only 30 kilopascal. And after application of the load at failure, when it is subjected to stresses, so at failure, the increase in pore water pressure, delta U, is 94.5 kilopascal. Naturally, it is after application of stresses. So when you apply the stresses and shear stresses, on vertical and horizontal planes, passing at point X equal to 0. So shear stresses have been given that there is no shear stresses. Naturally, it is the principal stresses. And C prime is given as 0 because it is fully saturated sandy soil. So the C prime, and phi prime is given to you as 36 degree. Calculate the shear strength. At point X. So let us see. It's simple problem now again. This 2018 important problem. So at a point X, what you have been given are the horizontal and vertical stresses. What is the horizontal stresses? It is 170. So sigma 3 is 170. And the value of sigma 1 is also given. Vertical stresses is 300 kilopascal respectively. Therefore, the normal stresses on the failure plane, you can find it out. What is the value of now phi here? Sigma n, you know the formula, equal to sigma 1 plus sigma 3 by 2 plus sigma 1 minus sigma 3 by 2 into cos 12. And therefore, we know that what is the value of alpha? Alpha is 45 plus phi prime by 2. So if you add up this 18 degree more, this becomes 63 degree. Therefore, you can substitute in one alpha value, and sigma and sigma 1 prime and sigma 3 prime are already known to me. I have found out the value of alpha. So if I substitute over here, I can find out the values of sigma n prime. So sigma n prime can be the normal, can be calculated. So let's calculate this. So it is going to be 176.79 kilopascal. So all these values are very important. Now sigma n prime equal to sigma n minus the pore water pressure. So a static pore water pressure, you know, plus the pore water pressure after application of this is known to you, this sigma n. So sigma n is already known to us as 176.79, and this pore water pressure can be calculated as we have got here, static, as well as you have got the at failure, there is the pressure, and static is this. So plus after application of stresses, this U, so minus pore water pressure. So this is 176.79 minus 30 plus 94.5. So if you simplify 176.79, so let us calculate this. So the value of sigma n can be calculated very easily by simplifying this term. And therefore, now the value of tau is going to be C prime, which is 0 here, plus sigma n prime into tan phi prime. Phi prime is already known to us. So if you substitute the value of sigma n prime and calculate this, you get the answer in kilopascal. So finally, you can get the value in kilopascal. So this way you can solve this problem of 2018. Another gate problem, we will take it. I hope you can apply the theory of shearing strength and calculate whatever is required very easily. Now 2021, there is another gate problem, which is a simple problem again. The most appropriate triaxial test. The most appropriate triaxial test to assess long-term stability of an excavated clay slope. Clay slope. So you have excavated the clay slope and you want to know the long-term stability of the clay slope is, and so many options are given to you. One is given CD test, consolidated drain test. Number two, which is given as B, is UU test, that is unconsolidated undrained test. The third option is given to you, consolidated undrained test. And the fourth option is given to you as UC test, unconfined compression test. Now you see here, you are performing triaxial test to assess long-term stability. In long-term stability, the pore water pressure is going to dissipate. And if the pore water pressure is going to dissipate for long term, you should always consider the drain test. Therefore, naturally, your answer is going to be CD test. So, your answer to this is consolidated drain test, CD test. For long term, you can't do UU test. If it is clay slope, it is for short term, and long term always you should go for drain test. So CD test. Friends, this is what I wanted to cover it today. I hope you will be able to do more problem on this in our next video. So thank you very much.